5 to 10 years from now, where is going to be the real value in the infrastructure of AI? Is it still going to be training these massive foundational models, or is it going to be somewhere else? And even more importantly, will Nvidia still be the king of that world, or is their grip already fading? To understand where the cracks in Nvidia's dominance are forming, we need to understand first where money is going, and that is inference. But first, what is inference and how is it different from training? Well, training is where a model learns and they process these billions of tokens to adjust internal weights and get better at predicting stuff. Whereas inference is where the model is actually used in the real world, whenever you write something in ChatGPT. Well, in the future, the vast majority of the value in the infrastructure layer of AI is going to be actually on inference and not on training. More than 95% of the value will be on inference and only 5% on training. This is because the vast majority of the computing resources and therefore money, energy and infrastructure spend all follow the computing resources will all go running through inference, which is running the actual model, not to training them. But why is that exactly? Well, if you think about it, when you train a foundational model, you do it once, maybe twice. If you think about the GPT-4, Claude or Grok from XAI, you can train them really one time only. But once the model is trained, you will run it millions of times, even billions of times each and every day. Think about every user message when you type something with ChatGPT, every query, every API call, or when you create an image. All of these things happen daily, and that is inference. So inference is really something continuous. You will have every single day for a continued period of time, whereas training is something you do once. And this is the fundamental reason why the vast majority of the computing resources will be in inference and not in training. But here is the twist. Although the vast majority of the action is and will be on inference, GPUs are actually quite bad at it. And here is why. During the process of inference, only 5 to 7% of the GPU is actually utilized. It's really like building a gigantic factory that can output 10,000 cars every single day, but actually you only need 3 cars per day. This is what is happening on GPUs at this moment. Only 5 to 7% of GPUs are utilized during inference. That's crazy. But why is that? Well, fundamentally it's because of the batch sizes. In fact, GPUs are optimized to have big batch sizes, but you really cannot wait 500 and plus queries when you ask something to ChatGPT to wait to get an answer. You want an answer right away. So we know latency is very important. You ask ChatGPT, what's the latest news about Trump? You want to know it right now. You don't want to wait ChatGPT to cluster 500 plus queries from different users and then process them all together. That's not realistic because you will have to wait. You would have latency, but you don't want that. And that is why the critical problem with GPUs is not really a computing problem. It's not a matter of throughput. It's really a matter of moving data. So it's a memory problem. This is why GPUs struggle so much on reasoning and agentic systems. AI agents are like a single player mode, whereas GPUs are really built for stadium gigantic crowds. Or said a little bit more technically, agents are latency bound. They are not really throughput bound. You care about having a response on time. You don't want to wait to reasoning for minutes. You want an answer right now. Or again, said differently, it doesn't really matter the tokens per second in aggregate, which is what GPUs are really good at. But you care about how fast you can generate one token for one user. GPUs are really designed for batch processing and maximizing throughput. But they really choke when they are asked to do something high speed for single stream inferences. And if we look at the problem right now is that the vast majority of companies are loading up on these H100s, which is the latest GPUs from Nvidia, the state-of-the-art GPUs. They are really buying a lot of these GPUs. Even though they are optimized for training and the technology of GPUs is really good for training, they are still using them for inference, despite the fact that the H100s are 5 times more expensive than the A100, but they do give you only 2 times the inference performance. And even worse, as we've seen, the vast majority of that performance is not utilized, sit there idle. What we are doing essentially is using $1,000 chips for a $10 job. Huge amount of inefficiencies. So the question here is, why don't people ditch Nvidia? And why are 40% of Nvidia's GPUs still used only for inference? Well, despite being very poorly optimized for inference, Nvidia's GPUs are used because they do dominate the developer ecosystem. And even very inefficient inference is still much easier to deploy on Nvidia. And also the vast majority of engineers are all trained on Nvidia's. And this is the first reason. The second reason is that once you buy all of these GPUs for training, because you can use them for inference, well, you might as well just do it. So companies, once they use the GPUs for training, since they have them there, they start using them also for inference. They are already deployed, so they reuse them. So it seems like Nvidia kind of have a big grasp on inference as well. Jensen Huang also mentioned that inference is a big opportunity for Nvidia. And is that true? And given the fact that GPUs are so bad and inefficient for inference, is he right? Well, actually he kind of is, because the thing about the GPUs is that they are there, they are available, you can buy them and you can use them for inference right now. Whereas the alternatives to GPUs, probably TPUs are the best state-of-the-art in the moment for inference, they are really not on the market yet. Either you can rent them, or if you can buy them, they are super expensive, so it really doesn't make a lot of sense. Even Cerebras, they are very good for inference, but they are hugely expensive. So yes, it does seem that Nvidia can win also inference. And if this was not enough, another problem that there is that the vast majority of chip makers have a go-to-market problem. So for example, imagine you have 10,000 Nvidia GPUs and they demand a high margin on these 10K Nvidia GPUs. Well, if you want to switch to, say, AMD, well, you would have to waste and give away all of these 10,000 Nvidia GPUs. But if you only have to buy, let's say, 3 or 4 times your capacity, so let's say you want to get to 50,000 GPUs, well, if you want to switch to AMD, the cost of losing the 10,000 GPUs that you already have, well, it's quite high, so there is a very high switching cost. So in a nutshell, Nvidia is absolutely not the best, they are just everywhere. Okay, so now we've seen that everybody is kind of stuck with Nvidia, and well, Nvidia is taking advantage of that, as they should. In fact, if we look at the margin cake of the infrastructure layer of AI, well, we start with chip fabrication. Companies like TSMC, they have a huge margin, like 60%. On top of that, there is Nvidia, who again stacks a 90% whopping margin. And then, if that is not enough, there is also all the cloud providers like AWS, Google Cloud, Azure, which also put a margin of 30%. And you, well, you are a very thin crust on this huge chip cake, which is why many argue is the reason that as soon as there is a viable alternative, everybody will flee away from Nvidia, or at least their margin will collapse. In fact, everybody is trying to escape this margin trap. And what is likely going to happen in the future, companies will increasingly more and more use whatever their cloud provider is offering at that moment. So for example, if you already have your whole company on Google Cloud, well, you might as well just use Google's TPUs, which are very good, and you won't have to pay the margin on Nvidia. Same if you're working on AWS, you might as well use Trainium, which is again very good for inference, and you don't have to pay the whopping margin to Nvidia. The problem is that you can only do it as long as the software becomes hardware agnostic, meaning you don't really need dependence on one single hardware provider like it is right now. The reality is that the vast majority of AI companies today do not own their compute. They rent it from Nvidia, AWS, or whoever has the chips. But the deeper you go down the AI stack, and the clearer it gets. If you do not own your compute, you do not own your margins. You are just another very thin crust on someone else's big cake. And in a world where AI inference takes 95% and even more of the infrastructure layer of AI, well, the winners probably won't be the ones with the biggest and smartest model. They will be the ones that control where this model ran on. Or said differently, the future of AI is not just about building the smartest AI possible, it's really about controlling where it lives. And maybe, just maybe, it's not gonna be Nvidia. Well, that's it for this video. I hope you liked it and I see you in the next one. Thank you.